Good evening, everybody. Welcome to Chem 1105 with your host, me, Dr. White. And tonight I'll be going through test number 2 review. But before I do that, a quick commercial from the management, me, or public service announcement. Don't forget to hand in your labs. They're easy points. Shh, don't tell anybody I said that. But you got to hand them in. Also, before you upload it to hand it in, make sure you've done all the lab and make sure you've answered all the questions for the lab. All right, let me just remind you, this Wednesday, I will be giving test number 2 online at about 8 p.m., 8 a.m., not 8 p.m., 8 a.m. or earlier. I'll send out a password for test number 2 PDF file, which you can download from the assignment area Blackboard. And you'll have until Thursday, 8 p.m. to finish test number 2 and upload your answers as a single PDF file to the assignment area Blackboard. If we are face to face, most students usually it takes anywhere from 40 to 50 minutes, but take up to 3 hours. You're home. Hey, I'll give you that extra time. Shh, don't tell anybody I'm being nice. Now, test number 2 will cover chapter 4 and chapter 5, part 1. This covers chemical bonding, including ionic and covalent chemical bonds, and it covers mole and mole-related topics, including balancing chemical equations. And it has 18 problems, 9 pages, no multiple choice questions, but some are multiple part. And here's the point breakdown. And you will need a scientific calculator. And there's five bonus points. See, it adds up to 105. But to calculate your percentage at the end of the semester, I'll only use 100. That's why it's 5 bonus points. Now, if we go to course information, click on lectures, and I'll be getting to the review in a little while, a couple minutes. You scroll all the way down, you'll see test number 2, important information, and you'll see test number 2, review. The slides I'll be using today are in this file, or if you can't open up an MS Word document, I also have it as a PDF file, which you can open up. If you can't open up the MS Word file. And speaking about files, let me open up one more file I forgot to open up. And that's open. All right, one other thing, let me remind you, tonight I'll have my office hour, and Wednesday night I will have my office hour. And if you ever need help, come and ask for help. Email me, come to my office hours. If you ever need special help because you can't come to my office hours, email me and I'll see if we can set up a private Zoom meeting. That's the nice thing about being in Zoom. All right, let's get started. Things you should know for test number 2. The first thing is how to draw a Lewis structure. How do you do that? First of all, you write down the element symbol, chemical symbol, and then you put 1 dot for each valence electron. And when you do this, you put 1 dot on each side, and I'll show you in a second, before you double up. Now, if I were to ask, draw the Lewis structure for sulfur, how do you do that? Well, on the periodic table, you should be using this one, and you'll be able to download this. It's in the same assignment as test number 2. You'll see sulfur S. If you look at the top of the column in red, is the number 6. Sulfur has 6 valence electrons. So how do we draw the Lewis structure for sulfur? It has 6 valence electrons. Chemical symbol is S. Put 1 on each side before doubling up. That's 4. I've got 2 more to go. Organic chemists usually top and bottom. This would be 1. Another 1 would be this. And there are 2 others you could draw. Whoops, I made a mistake there. Now it's correct. So 2 sides have 2 dots, and 1 side has 2 sides have 1 dot. So you put 1 dot on each side of the chemical symbol for the valence electrons, and then you double up. All right, next I talked about chemical bonds, and chemical bonds are the forces that hold atoms together in molecules. Cool stuff. And there are 2 types of chemical bonds you should know. The first one is an ionic bond, and you should know the definition that results from the transfer of 1 or more electrons from one atom or group of atoms to another atom or group of atoms. And next, we have covalent bonds. And covalent bonds results from the sharing. They're like holding hands, sharing. I always do that when I say covalent bond sharing. See, I did it again. And that results from the sharing of 1 or more pairs of electrons between atoms. Remember, pair means 2. Now, when we're talking about bonding, chemical bonds between atoms in a molecule, they follow the octet rule. I will never ask on a test, what's the octet rule, but you should know how to use it. And that is in compound formation, meaning forming chemical bonds, atoms of elements lose, gain, or share electrons in such a way they have their electron configuration become identical to that of the noble gas nearest to them. What that really means is they want 8 valence electrons. So if an atom loses electrons, it forms a positive ion called a cation. If an atom, an element, gains electrons, it becomes a negative ion. And when an element gains 1 or more electrons, it has a negative charge. It's a negative ion, and it's called an anion. Now, if I were to ask you, what ion does the following form? Say sometime in the future, like Wednesday, 3 points each. And by the way, what you're watching now will be on a video later today. I'll post. Anyways, let's say one of them is, let's pick magnesium. Well, how do you do this? Well, the chemical symbol for magnesium is Mg, which you learned for test 1. I hope you did. And then we go to our periodic table, and we see the atomic number for magnesium is 12. That means it has 12 electrons and 12 protons. And it wants to have the same number of electrons as the nearest noble gas. the gases, the elements in the last column on the right, with under the number 8. And if we notice, neon is at 10, 2 away. Argon is at 18, 6 away, which is the smaller number. And hopefully I'll pick 10, 2 away. So what does that mean? Magnesium has 12 protons and 12 electrons. And it wants to go to magnesium with 10 electrons, same number of electrons as neon, but it doesn't lose protons. Each proton is a +1 charge times 12 is +12. Each electron, there are 10 of them, has a -1 charge. That's -10. You add them together and you get a +2. Now we're not done yet. The question asks what ion, and you write an ion by its chemical symbol, Mg, and then the charge it forms, +2. And that's how you do that. Now, elements lose or gain, just like I just said. Ooh, electronies, that's definitely a spelling error. Oh, I created a new subatomic particle, electroniums. No, spelling error. Now, as I just noted, electrons lose or elements lose or gain electrons. They have the same number of electrons as the nearest noble gas. And you saw how I did that. Remember, elements never lose protons to form an ion. And if you had more electrons charged than protons, you get a negative ion. Now, an important thing, when I write things in red, it's important. All molecules have a net zero charge. So when we're talking about right ionic formulas, which is also called the empirical formula, based on charges of different ions, if I ask you to write the empirical formula for a molecule containing calcium +2, chloride -1, well, you have a +2 and a -1. It has to add up to 0. Well, it doesn't when there's only one chloride anion. But you can't change the charge, but you can change how many. And I can put a 2 here. 2 times -1 -2 plus +2 is 0. So there's 1 calcium, but this tells us there's 2 chlorine, and you do it that way. Now, for polyatomic ions, if I were to ask the same question, what is the empirical formula for a molecule with calcium +2, NO3 minus is nitrate -1? Well, this is a +2. This is a -1. It has to add up to 0 because all molecules have a net 0 charge. Well, it doesn't. I can't change the charge. Students try to, and it's always wrong. You can't. But I can change how many of them. If I have 2 of the nitrate, that will be a -2. This is a +2. Yay, we get 0. So how do we write that? We have 1 calcium. But when we have more than one polyatomic ion, you put it in a bracket. Inside the bracket, the polyatomic ion, and to the right superscript, how many? In this case, 2. And that's how you do it. Now, when we talk about this one, I just did our ionic compounds with ionic bonds, but covalent bonds, remember, are equal sharing of one or more pair of electrons. You should know there are three types of covalent bonds. The first one, single bond. And you should know a single bond is a bond in which two atoms share one pair of electrons. It's like single first base, one pair. The other type is a double bond. That's a bond in which two atoms share two pair of electrons, like going to second base double, two pair of electrons. And the final is a triple bond. And that's a bond between two atoms where they share three pair of electrons, triple third base. So single bond, one pair of electrons being shared, double bond, two pair, triple bond, three pair. Now, you should know how to draw a Lewis structure for molecules. And there again, we use valence electrons. And let's do something, oh, how about something stinky? H2S, hydrogen sulfide, is the smell of stinky rotten eggs, and it's stinky. Well, if I ask you to draw the Lewis structure, well, I've got hydrogen, two of them, and a sulfur. The first thing you have to do is find valence electrons. And if we go to periodic table, we have hydrogen has one valence electron, sulfur has six. So this has one valence electron, sulfur, six valence electrons. That's the Lewis structure for sulfur. Here's hydrogen. There are two hydrogens. Each one has one valence electron. And this hydrogen says to the sulfur, I have a valence electron. You have a valence electron. Let's share. And they do. The non-bonding pairs of electrons here and here come along for the ride. This hydrogen says, I've got one of the valence electron sulfur. You've got this one. Let's share. And that's how you do it. Let's do one more. And right now, hopefully you're all inhaling and exhaling oxygen. And how do you write the Lewis structure for oxygen gas O2? Well, you need to find how many valence electrons oxygen has. And you go to your friendly neighborhood periodic table, O oxygen, look at the red number above, it has 6 valence electrons. So we have 2 oxygens. And this oxygen says to this one, oh, I've got 1, 2 unpaired valence electrons. You have 1, 2 unpaired valence electrons. Let's share. And they do. And this is the Lewis structure for oxygen gas. What kind of bond, covalent bond is this? Well, it's 2 pair of electrons. That's a double bond. Now, one thing I forgot to mention with this one, but I'll do it here and I'll come back to hydrogen sulfide. If we look at this oxygen here, how many valence electrons does it have? Shared and unshared. If you count the dots, there are 8. octet, which it wants to do. If we look at this oxygen, how many shared and unshared pairs of electrons do they have? 2, 4, 6, 8. And it's got its octet. So you know you've done it right. Now, hydrogen is the only exception to the octet rule. Its octet is 2. So this has 2, this has 2. If we look at the sulfur, how many shared and unshared electrons? And the answer is 8. So it's happy. Isn't it nice to have happy atoms? Don't answer that. All right. Next, I talked about chemical equations. And you should know a chemical equation on the base of the arrow. Those are the reactants. And sometimes you'll hear me call them starting materials because I worked in the chemical industry for many decades. Yep, decades. And we call those starting materials. At the head of the arrow is always called the product. And you should know this. Now, because of conservation of mass law or matter law, you never create or destroy atoms. So in a chemical equation, you always have the same number and same type of atoms on the reactant side as the product. And if I were to ask on a test, balance the following chemical equation, before I show you how to do this, quick word from Dr. White, me. If I ask on a test to balance the chemical equation, you will always have to balance it on my test. The answer, it's already balanced, will never be correct on my test. I'll say that again. If I ask you, hint, hint, to balance chemical equation on my test, the answer, it's always balanced, will never, ever be correct. You're going to have to balance it. If I ask you to do it, you're going to have to do it. It's not fair to say it's already balanced. That's not fair. All right, so if you look at my advice in the videos, I think it's on the test number 2 review. We'll see when we go back to that. My advice is always leave hydrogen and oxygen last. Well, that means there's 5 carbons here. How do I get 5 carbons here? I can't change the formula, but I can change the coefficient, the number in front. So 5 times 1, 5 carbon. Well, that's balanced. Going this way, all I have left is hydrogen and oxygen. I'll do hydrogen. Here we have 12 hydrogen. Oh, on this side, we only have 2, but we need 12. How do we do that? Well, 2 goes into 12 6 times. So 6 times 2 is 12 hydrogen. Well, that's done. Here I have 2 oxygen. How many oxygen on this side? I have 5 times 2, 10 oxygen. I have 6 times 1, 6 oxygen added together, and that gives me 16 oxygen atoms on this side. Well, I have to have 16 on this side, so 2 goes into 16 8 times, and I'll have that coefficient. 2 times 8 is 16 oxygen, and now I'll check. 5 carbons, 5 carbons, 12 hydrogen, 12 hydrogen, 16 oxygen, 16, yay, it's balanced. And you should know how to do that. Go back and look at the videos, how I teach you the even odd trick. All right, let's move on. The next thing I've talked about is probably one of the most important concepts in chemistry, the mole. And you should know the mole is the chemist's counting unit. And by definition, 1 mole of an element equals Avogadro's number. Remember, 6.02 times 10 to the 23rd, you should know, is Avogadro's number. We did a lot of work determining moles and relationships of moles. Turns out, unfortunately, the actual 6.02 times 10 to the 23rd were discovered by 2 Germans whose names I don't remember. Most chemists don't. But 1 mole of an element equals Avogadro's number of atoms of that element. 1 mole of a compound equals Avogadro number of molecules of that compound. Now, another definitions of moles are 1 mole of an element equals the atomic weight of that element in grams. Excuse me. And 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of that compound is the sum of all atomic weights. Now, in the past, years ago, if you were in my 1105 class, you would have to memorize this. But as I mentioned in the videos, a number of years ago, a faculty member challenged me, are you testing people's memory and their knowledge of chemistry, or just their knowledge of chemistry? And I realized it was doing memory and knowledge. Now, important information, test number 2, this will be at the last, last page of test number 2. I will have what 1 mole of an element is equal to, Avogadro's number, atoms. 1 mole of a compound, that's Avogadro's number of molecules of that compound. 1 mole of an element equals the atomic weight of that element in grams. 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of the compound is the sum of all atomic weights of that compound. And what does that mean? You should know how to convert from moles of an element to atoms of an element, and the reverse of that, atoms to moles of an element. You should know how to go from moles of a compound to molecules of a compound, and the reverse of that, from molecules of a compound to moles of a compound. Now, let's take a look at this one right here, because the first 2 are similar. First one, I don't know, say 6 points. How many molecules, water, H2O, I hope y'all know H2O is water, are 8.31 moles of water. So what do you do? Well, if you've been watching my videos, I put a question mark. What are we trying to find? Molecules of water. What are we given? These many moles of water. And hopefully you've been watching the video and you've learned about your good buddy, your good friend, unit analysis. And here's what we're trying to, let me rewrite this right here. This is the only number we have to start with, so I am. If there were a ratio that I could convert to my answer, what units do I want my answer in? Right here, we figured that out. And now it's time to use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath. Now write those units in. And remember I taught if you have two things equal to each other, there are two possible ratios that you can form, A over B and not equal, and separate ratio, B over A. So where do I have a relationship of moles of a compound and molecules of a compound? Let's look at important information, test number 2. I'm looking for moles of a compound water to molecules of a compound. As for every mole of a compound, there's 6.02 times 10 to the 23rd molecules of that compound. Because I know that, I know A equal B, 1 mole of water is 6.02 times 10 to the 23rd molecules of water. Now, before I find my calculator, which is hiding right over here, I'll check, do I get the right units? And notice this is moles of water divided by moles of water. And anything divided by itself equals number 1, meaning it cancels out. And I'm left with molecules of water, yay. So now I'll pick up my calculator, turn it on, I'll clear it. I have 8.31 times 6.02, remember, double E or second key, blue double E, and that's 23rd. I'll hit enter, and my calculator gives me this number, 5.00262 times 10 to the 24th. Now, remember, and we'll say on test 2, like test 1, please use proper significant figures for all calculated answers. And for multiplication division, you get the same number of significant figures in your answer as the number that has the fewest significant figures that you're multiplying dividing by. This is 3 significant figures. This number is 3 significant figures. This is part of the definition, so it's an exact number and plays no role. What's the lowest number? Well, either case 3. So I round this off to 3 significant figures. Keep the 5, keep the 0, keep the 0. Use the 2 to round off. When it's 4 or less, you just drop it. When it's 5 or higher, you drop it. And the number in front, you increase by 1. Since it's 4 or less, the correct answer here is this. And that's how you do it. Now let's look at the next 2 ratios dealing with moles. A mole of an element is equal, it says how to convert a mole of an element to grams of an element in reverse, and a mole of a compound to grams of a compound in reverse. I like compounds better than elements, so let's do this one. All right, say 8, 10 points. How many moles water are 2.43 times 10 to the third G is grams of water. So what are we trying to find? I'm putting a question mark, mole of water. What are we given? We have 2.43 grams of water times 10 to the third grams of water. So the only number we have to work with here is this. And if there was some ratio I could convert it to, what units do I want to convert it to? Well, we determined that by what are we trying to find? Moles of water. And guess what time it is? It's time to use your good buddy, your good friend, unit analysis. I love my whistles. These come from a company that's no longer in business and from West Germany. I have 4 of them and they never leave my house. So whatever we're trying to get to, the units go on top of that ratio. Whatever we're trying to get rid of, the units go underneath. And I'll write that now. Grams of water on the bottom, moles of water on top. And where do we find a relationship between grams of a compound and moles of a compound? If we look at important information, test number 2, 1 mole of a compound equals the molecular weight of that compound in grams. But you also have to remember the molecular weight is the sum of all atomic weights in that compound. So the first thing, this is 1 mole. This is the molecular weight, abbreviated by the MW, of water. Oh, we've got to figure that out. Now, the molecular weight of water is the sum of all atomic weights. Well, there are 2 hydrogen and 1 oxygen. Well, where do we get those atomic weights? From your periodic table. Now, on test 2, as I've mentioned in the video, it will say, please use all atomic weights, the 3 significant figures. So round off 1.01, I already got ahead of myself, 1.008 to 3 significant figures. Keep the 1, keep the 0, keep the 0, use the 8 to round off. That's 5 or higher, so you drop that. Number in front becomes 1.01. If we look at oxygen, 15.999, keep the 1, keep the 5, keep the 9. Use the 9 after the first one, after the 5 to round off. That's 5 or higher. You drop those 2 9s, increase this 9 after the 5 by 1. That's 1.0 to 15, 16.0. So there are 2 hydrogens, and each one has a atomic weight of 1.01. There's 1 oxygen. It has an atomic weight of 16.0. This equals 2.02, 16.0. Now, when we add them up, we get 18.02. Now, significant figures for addition. You get the same number of significant figures to the right of the decimal as the number that has the fewest significant figures to the right of the decimal. And all numbers, including zeros, are significant. So this has two significant figures. This has one. We're only looking at what's to the right of the decimal. These right here. What's the lower number? This, 1. So how do we round this off to 1 past the decimal? Keep this, use the 2 to round off. That's 4 or less, and I drop it. So the correct molecular weight, which you should know how to calculate for water or any other compound, is 18.0. And now, before I pick up my calculator, before I pick it up, I'll check my units so they cancel out. Grams of water divided by grams of water. Anything divided by itself becomes the number 1, cancels out. So this cancels out. I'm left with moles of water, the right unit. So now I'll pick up my calculator, clear it, 2.43, double second key, double E, 3 times, oops, excuse me, I made a mistake there, divided by 18.0. And my calculator gives me this number. And if I look at this, remember all calculated answers you should put down to the proper, use proper significant figures. This is 3 significant figures. All non-zero numbers are significant. Significant is 0 after decimal is significant. So that's 3 significant figures. This is an exact number. That's definition. Exact numbers play no role. So you got the same number of significant figures in your answer as the number that has the fewest. In both cases, again, we got 3. This is 3. We're done. Now, important word, this problem and the one before. Show your work. If you make a mistake, like when you're doing your calculator and you just say you wrote down the answer here, by the way, this is wrong. You wrote that down and you didn't show your work, I'd give you 0 points. If you showed all this work and you wrote down this, I'm going to say, oh, you made a math error because you knew what you're doing. You might have pressed the wrong button on your calculator, and I'll take off 1 point. And if it was 8 points, you'd get 7 instead of 0. So it always pays to show your work. Now, the last topic I want to cover for test number 2 is called mass calculation for reactions. And you have to do 3 steps to solve this type of problem. And this type of problem, you're always given a balanced chemical equation because the coefficient of a balanced chemical equation gives you molar ratios. And the first step, whatever you're given the weight of, mass of A, you convert to moles of A. And I'll be showing you this in a little while. Second step, moles of A, you convert to moles of B. And the third step, moles of B, you convert to mass of B. So let's look at how do we do something like this? All right, let's look at this problem. How many grams of water are formed when you react 4.173 grams of hydrogen with an excess of oxygen? Well, what do? Well, hint, if you're given a balanced chemical equation, it's going to be the 3-step. But what are we being asked? Excuse me. What are we being asked to find? Grams of water. What are we given? This 4.173 grams of hydrogen. And you're given this balanced chemical equation. There's no way I can go from grams of hydrogen to grams of water in one step. You can't. So you need 3 steps. And good news, you don't have to memorize these. They're important information. Test number 2. The first step is whatever we're given the mass of in grams, we convert that to moles. We're given grams of hydrogen. We want to convert that to moles of hydrogen. A is whatever you're given the weight of. So I have 4.173 grams of hydrogen. I want to go to moles of hydrogen. And it's time to use your good buddy, your good friend, unit analysis. Whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of unit-wise goes underneath. And if you look at important information, test number 2, 1 mole of a compound equals its molecular weight in grams, and the molecular weight of that compound is the atomic weight, sum of all atomic weights. So we need the molecular weight of hydrogen. MW is shorthand for molecular weight. And we have 2 hydrogens because it's H2. And what's the atomic weight? Well, we did that earlier. Look at the periodic table, round it off to 3 significant figures. Oh, let me not cheat you. Here's hydrogen, round that off to 3 significant figures, 1.01. And if I do the math, 2.02. So for every 1 mole of hydrogen, gas H2, the molecular weight, there's 2.20 grams of hydrogen. Now, before I pick up my calculator, grams of hydrogen divided by grams of hydrogen, anything divided by itself equals number 1. This cancels out. And now I'll pick up my calculator, clear it. And now there's 2 ways of rounding off in a multiple step. You can do it at the end or each step. I'm an each step person, but I'll calculate it either way, and sometimes the answers are different. Now here, to 3 significant figures, you get this number. Are we done? No, we're trying to get to grams of water. So now we have to do step 2. And what's step 2? Moles of whatever we just calculated, you convert to moles of your answer. Moles of A to moles of B. So we just calculated And what are we trying to get to eventually? Grams of water. But in this step, we need moles of water. Oops. So I have moles of hydrogen. I just calculated in step one. I'm going to use my good buddy, my good friend, unit analysis. I'm trying to get to moles of water. And using unit analysis, whatever I'm trying to get to, oops, thought that should be red. Let's try this again. There we go. Goes on top. Whatever I'm trying to get rid of goes underneath. And where do I get a relationship between moles of one compound and moles of another? Well, if we look at important information, that's the wrong thing. I don't have it on there, but I do have it in the review. And that is, remember, this one thing you should memorize. The coefficients of balanced chemical equations are molar ratios. So if I look up here, my balanced chemical equation tells me 2 moles of hydrogen react with, when there's no number there, it's the number 1 mole of oxygen to give 2 moles of water. So the relationship is for every 2 moles of hydrogen, we make 2 moles of water. And these are always coefficients, exact numbers. So if I come back here, for every 2 moles of hydrogen, I make 2 moles of water. And notice moles of hydrogen divided by moles of hydrogen cancel out, because anything divided by itself equals number 1. And guess what? I don't have to use my calculator here. This is 3 significant figures, exact number, exact number. Am I done? No, I'm trying to get the grams of water. So now I need to do step number 3. And if we look at important information, test number 2, step 3 is convert moles of B water to mass of B water. So B is water, moles of water to grams of water. And we just calculated we have 2.07 moles of water. We want to go to grams of water. And it's time to use your good buddy, your good friend, unit analysis. Whatever we're trying to get to goes on top the units of the ratio. Whatever we're trying to get rid of goes underneath. And here we have grams of water, moles of water. And where do we get a relationship between grams of water and moles of water? We look at test number 2, important info, wrong one. Let me get the right one. I did have the right, all right. And 1 mole of compound equals the molecular weight of that compound in grams. And the molecular weight of that compound is the sum of all atomic weights. And remember, you get the atomic weights from the periodic table. And water has 2 hydrogen, 1.01 to 3 significant figures, 1 oxygen, 15.999 becomes 16.0. So we need, for every 1 mole here, we need the molecular weight of water, which we calculated earlier, but let's do it real quick. 2 hydrogen, 1 oxygen. .01 is the atomic weight of hydrogen, 16.0 atomic weight of oxygen. Do the math, add them up. Remember, you get the same number of significant figures to the right of the decimal as the number that has the fewest. This is 2, this is 1. Keep this, drop that. And now moles of water divided by moles of water cancel out, because anything divided by itself equals the number 1 is gone. I'm left with grams of water. That's what I want. And now I will clear my calculator. 2.07 times 18. I get this. This is 3 significant figures. 3 significant figures. The 1 is definition, exact number. Keep the 3, keep the 7, keep the 2, use the 6 to round off. It's 5 or higher, drop that, increase that by 1. And the correct answer is this. And remember, you can round off at each step like I do, or wait till the end. And with that, I'm done. Remember, show your work on test number 2 for problems like that. If I had made a math error, you would have gotten 0 points if you didn't show your work. But if you show your work, you would have gotten full credit. So don't forget, on Wednesday, I'll be giving test number 2. It will be due at 8 p.m. on Thursday. You'll have up to 3 hours to take it. Take your time. And if you have any questions between now and then, let me know. Because remember, in my class, there's no such thing as a dumb question. With that, I'm done. I've got to switch to the other login for my office hour for this class and my other class. Any last minute quick questions before I leave? Katie, Alex? I got my speaker on. When I first started Zoom, I forgot to turn it on. All right, with that, I'll say gang gesund. Bye now. And if you want, log into my office hour and I'll be there. I'll see you. Bye.